All right, let's pull back the curtain on programming and look at the powerful, unseen forces that actually make code work. We're talking about operators, the hidden language that tells your computer exactly what to do. I mean, really think about it for a second. We just write lines of text, but somehow that text can calculate, it can make decisions, it can create whole worlds. So, how does that happen? How do we get from these static instructions to dynamic, living action? Well, the answer lies in some very special symbols. And that's the perfect way to think about them. An operator is basically just a symbol that tells the computer, hey, do this, whether it's math, a comparison, or some kind of logic. For this whole explainer, let's imagine we're building a programmer's toolbox. Each operator is a different tool with a very specific job. Learning to use them is how you build, well, anything. Okay, let's pop open that toolbox and start with the tools you probably already recognize. This is our basic math toolkit, the absolute workhorses of programming, the tools you'll use for any kind of calculation. So in the world of code, the things that operators work on are called operands. Let's just take two numbers, 25 and 5. So if we take the addition operator, yep, just a simple plus sign and stick it right between them, we're giving the computer a clear command. Combine these two values. So what happens next? And bam, the computer performs the operation and gives us a result. In this case, 25 plus 5 gives us 30. It's that simple. The key thing to remember is that an operator takes some operands, performs an action, and almost always gives you back a new value. It's the fundamental building block of all computation. And of course, it's not just about adding. Your basic toolkit is fully loaded. You've got your subtraction, multiplication, which, by the way, uses an asterisk in most languages, and division. There's also this really cool one called the modulus operator. That one gives you the remainder after a division. They all work just like you'd expect. But, programs are more than just fancy calculators. They have to make decisions. They need to be able to react to things and choose what to do next. And for that, we need a totally different set of tools for comparing things. This is where relational operators come into play. You can think of them like a set of scales. They're all about comparing two values. For example, we can use the greater than operator, that little greater than symbol, to ask the computer a really direct question. Hey, is this value on the left, 25, bigger than the value on the right, 5? And the computer doesn't hesitate. It gives us a clear, simple answer. True. Now, fun fact, in a lot of programming languages, like C for instance, true is actually just represented by the number 1, and false is represented by 0. This simple true or false logic is the absolute foundation of all decision-making in code. Now, here's where it gets really cool. We can start combining these simple true-false questions to build some pretty complex logic. You use logical operators for this. So for the logical and, both things you're checking have to be true. Think about it. For something to be a burger, you need a patty and a bun, right? The logical not is even easier. It just flips the whole thing. If something was true, now it's false. Okay, so the more you code, the more you start looking for ways to do things a little faster, a little cleaner. That's where our next set of tools comes in. These are the clever shortcuts that help you write better code without repeating yourself. This right here is a perfect example. A super common task is just updating a variable's value, like adding 5 to it. Now, you could write it out the long way, as you see in step 1. It works, sure, but check out the shortcut in step 2. That plus equals operator does the exact same thing, but it's way more compact and elegant. And this isn't some one-trick pony either. This kind of shortcut, called a compound assignment, works for almost all the math operators. You can multiply and assign, subtract and assign, you name it. It's a simple little tool that just makes your code that much easier to read. All right, let's shift gears. It's time to get a bit more advanced. For our next set of tools, we're literally going under the hood to look at the things that let us speak the computer's native language, the language of ones and zeros. This is all about speed and ultimate control. Because here's the thing. Deep down, computers don't think in terms of numbers like 25 or 5. At their core, all they understand is on or off, a series of ones and zeros. We call these bits. Every single piece of data on your computer is ultimately just a long pattern of these bits. So if you want to work at that level, you need special tools. And that's exactly what Bitwise Operators are. Instead of adding numbers, they perform operations directly on the individual ones and zeros themselves. This gives you incredibly fast, ridiculously efficient control that you absolutely need in high-performance stuff like graphics programming or processing data straight from a network. To finish up, let's just take a quick peek at a few other multi-purpose tools. These don't really fit into one single category, but they are incredibly useful for rounding out our toolkit. So let's do a quick fire round. You've got the size of operator, which tells you exactly how much memory something is taking up. Then you have the conditional operator, that weird question mark colon thing. It's basically a super compact if this, then that, otherwise this statement. And then you have the address of operator, which tells you the exact location of a variable in the computer's memory. Super powerful stuff. And there you have it. We've assembled a complete and really powerful programmer's toolbox. We've got our tools for doing math, tools for making decisions, tools for writing cleaner code, precision tools for low-level control, and even a few miscellaneous specialty tools. With this kit, you're pretty much ready to tackle any problem that comes your way. So you see, these symbols are so much more than just characters on a screen. They are the verbs of programming. They're the actions that turn your ideas into a reality. The toolbox is open. It's packed with everything you need. So the only question left is, what are you going to build with it?